So this is managing technical debt. There's a bit of a Django twist to it. So I guess out of curiosity, how many people here use Django and want to know more about Django? Okay, so I'll do those slides then. So I am Chris Chang. You can find me on GitHub. My Twitter handle is CCRRCCRCCRR. I'm also on IMDb. I am Chris Chang too. And you can also find me on Pinterest, cPanel. I'm currently at Tabbed Out. Tabbed Out has a bunch of Django projects, but we don't use it the way you use it. We really just use it for Django REST framework. And but formerly I was at the Texas Tribune, which heavily utilized Django, and could go on about how we used it there too. And for this talk, if you have questions, I think you should go ahead and ask them as they come up. You don't have to wait till the end. So I like to start off with, everyone just starts off with dictionary definition. Wikipedia says, technical debt can be thought of as the work that needs to be done before a particular job can be completed or proper. And Gene Kim has said, left unchecked, technical debt will ensure that the only work that gets done is unplanned work. And in my opinion, every line of code ends up being technical debt. Something else that Gene Kim says is technical debt. I don't want to give him two quotes on the same slide, but here it is. Technical debt is what you feel the next time you want to make a change. And just in case you're wondering, there isn't an Urban Dictionary definition for technical debt. So what does technical debt feel like? It's what happens when you fix one bug only to create another one. It's what happens when you can't deliver features anymore because you don't know what will break. And it can be so bad where you can't even do security patches because you're afraid of any sort of change. And if you're using Django, the thought occurred that we're using this rapid development framework and we're no longer able to rapidly develop. That's kind of when technical debt really sunk in for me. And it's also of when you hear a lot of, it works for me around the office. And generally, when everything is on fire all the time. So definitely whenever I'm working on a project with a lot of technical debt, this is my general life. And there is no magic trick for getting rid of technical debt. There's no one weird old tip that will help you out. So here's some tips. I've generally organized them in terms of things that you can change on your own, things you can do among your own like technical team, and things that you have to reach across to the business side, outside of your team, up to the whole organization. So the main thing is, if you're not writing tests, you should do it. Don't let your dreams be dreams. Yesterday you said you would write tests tomorrow. Just do it. Make your dreams come true. Just do it. If you're not used to writing tests, you may wonder, when should I write tests? And something that I like is anytime you're making an assumption, that's a sign that you should be writing a test. And if you're new to testing, you may decide to scrimp on writing tests up in the beginning, but whenever there's a bug, you should always be doing regression testing, because having to fix the same bug multiple times is just embarrassing. And as a wise man once said, fool me once, shame on you. Fool me, can't get fooled again. And the fact is, you will sleep better at night when you have good test coverage. So what I mean by testing an assumption, let's say I just wanted to normalize my zip codes to 5 digits. Well, if I just take the first, do a slice of the first 5, that ought to work, right? Well, here I've written some tests using the docs test convention, and you can see that my simple assumption that I could just do a slice kind of starts breaking down. And if you don't have a single test, a great one to start off with is just use the Django test client and grab your home page. And another good way to remember whether you should be writing a test or not is if you liked it, then you should have put a test on it. So along with testing, coverage comes up a lot too. And for me, coverage is just a tool to figure out where you're missing your tests. If you have 100% test coverage, but you have crappy tests, then going for the 100% number wasn't really the goal you should have been striving for. So to me, some signs that your tests are crappy are, can other people read and extend the test you wrote? Are your tests getting maintained by other people, or are they a source of frustration? And something that I'll kind of mention a few times is, do your tests describe the problem in a way where someone could throw away the code and recreate it using just the tests? And the next thing I want to cover is basically just bit rot. If you're not touching a piece of your code base, it's probably just getting worse. And if you're not, if you don't have the manpower in your team to just continuously touch on your whole code base, it's probably a smell that your code base is too big. And Mike Rother has something called the improvement kata, and you may also heard of it as the Toyota kata, that if you're interested in this, it's something you should investigate. It doesn't apply just to software. And someone once said, applications age like fish. Data ages like wine. And we've all seen or added the comment in our own code, like here be dragons. That's when you see that, that's a sign that you've got some bit rot in your code base. So something you can use to help tackle bit rot is continuous integration. I really like this one quote that says, any task you do at least once a month should take less time than it takes to get a cup of coffee. I'm a really big firm believer in automation. And some tools you can use are Jenkins, Travis CI, Tox, and there's actually a pretty good intro guide to all these tools and more at this link. And the really great thing is once you have a documented, reproducible environment, it solves a lot of it works for me, things that pop up. And if you can automate away routine things, it frees you up to do more exciting creative things. I like to refer to this XKCD a lot, just to decide whether or not it's worth spending the time to automate a task. And it's kind of funny because there's another XKCD saying how you should never automate, basically. So code quality also is a big deal. But the only way I know to get better is to go to conferences or to just practice. One thing that I like a lot is just making sure to write simple, easy to understand code. I think a really good example of that was, if you remember James's keynote yesterday, he wrote the same thing 3 times. You can solve problems multiple ways, but to reduce technical debt, the solution that requires the less context to read It may not even necessarily be the simplest code, but the one that requires the less context to read is probably the most maintainable one. So to know what context is appropriate, you have to know your audience. It's usually just your teammates. If you're open source, then it's the open source users. And it can even go beyond to if you have a user interface, you can go directly to your users too. And with Python, I always choose readability over performance, except for, yeah, most of the time I choose readability just because having to maintain performant code is a lot worse than trying to maintain readable code. And whenever I have to think about this, I like to have import this. But I usually I just did that and I printed it out and I put it on my wall next to my desk. If you're not familiar with that, it looks like this, except I wanted to show that, does anyone else always constantly misspell import? I do. But. So Python has this great thing built in. They care about code readability. And if you do import this, you get this little thing called the Zen of Python. And I just took the first part here, but beautiful is better than ugly, explicit is better than implicit, simple is better than complex, and on and on. So whenever you're making a design decision of how you should be writing your code, this is a pretty good reference. And if you follow this, this comes up a lot too when people talk about, oh, this code is Pythonic or not Pythonic. And this is kind of a crude example I came up with where there's two ways I could approach this problem. The first way, I'm using the map and an operator. And I really like using maps. I hope to get my coworkers to use them, to like them more. But every time I use map, in code review, my coworkers say, you should use a list comprehension instead, because it's more readable. And so I do it. But it comes down to, if you're in a shop where everyone's used to writing functional code, then the map may be more appropriate. So in terms of code quality, there's a lot of related topics you can dive into more. So like a really great one is whether or not comments help or hurt your code. And there's a really great topic I like called cyclomatic complexity. And it goes along with macabre. And it's a way to quantify how readable your code is. And the great thing about that is you can plug it into a Jenkins job and you can track how readable your code has gotten over time. And there's always PEP8, which has been mentioned a few times here. I'm a pretty big fan, even when it tells me to do things I don't necessarily agree with, but over the long term, I've grown to embrace it. So the single most practical way to get better is code review. And a lot of people will say, people take too much time to review my code. Sometimes we'll say, like, I'm the boss, or I'm the big boss. And a lot of times people say, something's broken in production. We need to get this hotfix out. But just think back on your own life. How many times did coding under pressure actually fix the problem? But let's say you're on a very small team, or you don't have a team. Is there a way you can still do code review? And I think there is. What I usually do is I just sleep on it. I always open pull requests anyways, just because it gives you a fresh context of seeing all your code in one place. And the really great thing about, I think this quote also really applies to code review, and as iron sharpens iron, so as one person sharpens another. And the way we usually go about code review is a pull request. It may be called other things in different different tooling, but a pull request or diff. The general rule is if you want your pull request to get reviewed quickly, is you have to make it as small as possible. So kind of along with like single responsibility, the general rule is one pull request, one change. But if you're trying to manage technical debt, you should bend this rule a little bit. There's something called the Boy Scout rule. When this was mentioned to me, I thought it was it be prepared? Because that could have some like code. It's not that. It's I thought then it might be like do a good turn daily. It's not that either. Turns out it's like leave the world a little better than you found it. And the idea is when you're writing code, you're around, you're touching other stuff, and if you happen to see a typo, if you happen to see some inconsistent style, you just go ahead and clean it up while it's in front of you. And the point at which you should probably stop doing that is if you have to modify a test in order to do this little cleanup, leave it alone because it's going to make the pull request too hard to read. But you should make a note of it in your issue tracker to revisit as a piece of technical debt that you've identified. So when I'm reviewing a code review, it's a lot more than syntax. A lot of times I'm looking for, is what someone wrote repeatable? Did they do the right documentation to go along with it? And is their approach maintainable? And these are all things that are a little extra that you don't normally think of when you're doing code review, but you should consider if you're trying to maintain technical debt. And a really good example is of code reviews is looking at Raymond Hettinger's Beyond PEP 8. I know I've heard it mentioned at least one time here already. And I think is a Django example of something maintainable is sometimes when you're trying to get something into a template, you may think that you should use a custom template tag to go about doing it. But a lot of times, I see having to use a template tag as a smell that you might be doing the wrong approach. I usually try to do it in the view itself or with jQuery. So something I like to do on my pull requests is something I stole from the government. I like to attach a technical debt note to a lot of my pull requests. And I think looking at this is from the Legislative Budget Board, like their definition of what a fiscal note is a pretty good, gives you a good idea of how I like to describe the technical debt involved with a pull request. And that's a fiscal note is a written estimate of the costs, savings, revenue gain, or revenue loss that may result from an implementation of requirements in a bill or joint resolution. It serves as a tool to help legislators better understand how a bill might impact the state budget as a whole, individual agencies, and in some instances, local governments. So you really have to just look at the impact on your whole organization of this technical debt that you're creating with every pull request. And you may not come up with a lot of these yourself. They may come up in code review, like things that might be, if you're adding a snowflake pattern in your code that's not used anywhere else, that's a little extra technical debt. If you've touched request.user and now your view suddenly has a vary cookie on it, that's something that you may not realize you're doing. Oh no. Yes. So Beyond code review, there we go. Beyond code review, pair programming really takes code review and just kicks it up a notch. Bam. So the way I like to do code review that I never get to do because no one else uses these tools is tmux and vim. But you don't need to have special tools to do it. You can just have two people in front of a computer, both talking and reviewing and talking about solutions in real time. And there's another approach that I learned about that I'm interested in called ping-pong pair programming. And the idea is one person writes tests, then the other person satisfies those tests, and they flip back and forth. I'm very curious if anyone's ever actually done that. And just going beyond pair programming, it's important that your team as a whole is aware of technical debt and is mindful of the approaches to minimize that. And a lot of that happens at the hiring level. Like a lot of times whenever we hire a tabbed out, we always ask, how do you deal with code review? Or what is your code review experience? And I've definitely worked with a lot of people before and no longer work with them anymore that basically just refuse to do code review. But a really good thing to remember though is that the past you is probably the worst coworker you've ever had to deal with. So in terms of office culture, always think about how to get faster feedback loops about everything. So that's going out to your designers and talking about design. Just make sure that feedback process is faster. Whenever there's specs, whenever there's review, basically anything where you need feedback, you want that to be faster. That goes for deploys too, getting faster feedback on how your code actually does in production. Anything you can do to make things go faster will help a lot. Another thing is just learning how to say no, like learning how to do real project management. I've been at a lot of organizations where there's just this steady stream of small tasks that just come in and your backlog just it's monotone increasing. And another thing I really like is learning to embrace failure. Like a lot of times we try to protect ourselves and we don't fess up to what happened, or you don't, like breaking the build should not, or breaking this production site should not be seen as something wrong. It should be a chance to learn something and to improve the process. So something that I've personally been working on a lot lately is basically kind of making myself look like an idiot as much as possible, just by fessing up to all the things that I've made mistakes on. Another thing that I really like doing too is work really hard to make yourself obsolete. With automation, with documentation. If you're always working like you're training your replacement, then that means you're communicating all the knowledge that you have. And it also goes along with what I said earlier with automation. If you can automate away all the boring stuff, you can work on the really cool creative stuff too. And a litmus test for this is, can you go on vacation without your laptop? Or are you chained to the office? Now, another thing you can do with your organization is admit that technical debt is a problem. Then maybe you can start tackling technical debt as a feature instead of always, instead of it just always going on the wayside and piling up. It's really hard to communicate to the business side of organizations that technical debt is a real thing that has real impact. So I think that the seeds of technical debt are often sown upstream by product development. And so another thing I like to do is just write up a list of all the technical debt that I can think of. It's really cathartic, and it actually turns out to be really helpful. And I like to use the system of emojis. I use the flame, the poop, and table flip over. So what I do is I have a short description of the task. I usually have more columns than this, but for readability of this presentation, I use flames for how big of a problem this technical debt is. I use poop to denote like how potentially embarrassing to the organization this is. And I use the table flip to describe how hard is it to actually fix this problem. And when you sit down and write it all out, one thing that you discover is you can identify low-hanging technical fruit that you can just bang out in your maybe do it while you're not at work, because it's fun. Another thing that I've kind of learned over the past, I guess it's been 2 years now, but the Agile process is actually pretty useful. This kind of goes back to faster feedback loops. That's the main thing that I like about the Agile process. But I think a lot of it is also just common sense. So even if you're not using Agile at your current place, it's worth looking into the philosophy and seeing what you can learn from it. I really like how one of the goals of Agile is to just continuously improve the process. So what you're doing now, it may not even be related to the actual product development and coding, but just improving the code review process and the way you communicate as a team. I found that it's really helpful. So I really like Django. I think Django helps a lot with managing technical debt. The greatest thing about Django, I think, is the way it's easy to do tests. I've tried doing testing with some other frameworks, and I always go back to Django. And Django gives you a lot of batteries. So there's less boilerplate, there's less code that you're having to write and maintain. And it's also got a great community so that you can get features, even if it's not included, and there may be a feature that someone else has already written and it's well maintained. So one tip, this is probably one of my biggest lessons learned, is don't customize the Django admin. Think of the Django admin as the developer's interface, not as a CMS. I can't tell you how many times, actually I can, it's every Django version. I have not been able to upgrade any Django version. It's so painful because the Django admin changes all the time, and if you're building off of that, then you're pinning what you wrote to what happened to be in Django at the time. So it may seem like you're writing more work. It may seem like it's more work to just do it all from scratch. But instead of being pinned off of Django's admin, which changes often and in breaking ways, if you're doing it yourself, then you control everything and you can freeze your CMS interface without having to rely on the admin. And you can even reuse bits of the admin. That everything except for all the Python code that powers the admin, that is good, and you can rely on that. Oh, yeah, so it's a great way to describe it is now you're tightly coupled to the Django admin, and as we all know, you don't want to be tightly coupled to that. Instead of doing your own Django admin customizations, you should look into using someone else's. And when you're evaluating a Django package, I mean, you probably have your own process of seeing how active and maintained it is, whether or not they upgrade along with Django. But there's a lot of them. So always look outwards before you think about writing something, reinventing the wheel. And another thing that I like to do a lot is clean as you cook. This also kind of goes along with the Boy Scout rule. I like to just delete code. For a while, I would comment stuff out, but that's what source control is for. And one thing I like doing now is if there's a block of code that you think is actually going to be useful, I don't comment it out. I put it in an if statement. I'll just wrap it in an if false. And that way, it turns it more into a feature switch rather than a deletion. Because if you generally want to like turn it on and off, now when you're doing code change, it just becomes changing that if statement. And if it is something you are actually turning on and off, you could turn it into a full-featured Django waffle switch too. Another thing I think is really important is just be better at naming things. Like single-letter variable names are pretty much never a good idea. And with tooling now, it's really easy to do find and replace. And if you're using generic reused names, doing that is painful. So a lot of times when I come up with a name, the first thing I think of is it greppable? I like to use unique names for apps and my models, even though Django doesn't really care about that. But I found that there's enough places where it matters where I just do the extra effort up front to have those unique names. This is especially true when I use Django Shell Plus. I'll go into that a little later. And the thing that I really happened upon about a year ago is you should really name your variables, especially in tests. So I have an example for that. So it used to be that I wanted to write tests quickly, so I'd use a lot of single letter variable names. And the only thing worse than a single letter variable name is a single letter variable name and then a number. So Django has something called, I use something called factory boy. And the great thing about that is if I needed a model for a test, and that model has required fields, in the setup for the test, you've got to set up all those required fields too. And so when you're reading the test, you're not sure how much of that setup is to do the test and how much of that is just to satisfy the validation of the model. But if you use Factory Boy, it's a lot more readable. In my example here, I'm only concerned about the active field. And then I also changed my variable from just A to article. So now my assertion reads, article is in article.objects.active instead of just A. And this really pays dividend when you're revisiting tests, even like a week later. And I really like using this called Shell Plus. I guess how many people know about it and use it. Yeah, it's really great if you're lazy, and I'm really lazy. So here's a example project, and let's say I wanted to know how many elevators there were. If I did this with in the normal Django shell, I would go in there, and then I would have to go in and remember the import. But here, with Shell Plus, it basically reads all your apps and imports everything for you, which means you can get in and start doing the fun stuff right from the bat. But if you have model names that collide, then you're never sure which one exactly that you're using. And Shell Plus actually has things built in to help resolve that. But it seems like you're just adding more tooling on top of tooling when you could have just had better names to begin with. And another tip I've got for Django is avoid the test client. I know in a lot of the example codes, when you're in their testing views, they usually use the test client. And just think, if you're writing a unit test, you probably shouldn't be using it. If you're writing an integration test, you should definitely be using the test client. And if you don't know why, it's because when you're using the test client, you're not only hitting your view, you're also hitting the URLs layer, the request middleware. Then you finally get to all the layers of your view, and then there's another the response middleware and context processor. Maybe there's even more things than that. I don't really know. It just touches a lot more than when you think you're touching. And a really big thing I also learned with Django is you should avoid model inheritance. You should really have to fight to use mixins and base classes when you're doing your Django models. Going back to Django extensions, if what you want to do is also a mixin in Django extensions, it's probably a good idea. I wouldn't necessarily use Django's extensions version just because then it's an extra requirement that has to be installed. But having a timestamp field or a auto slug field, that might be worth using a mixin, but if something happens to be repeated across a few models, that probably doesn't justify turning it into a mixin. Mostly just because it just hurts readability. Another thing I like to do is every time I do a pull request, I like to just see what requirements changed. And if I can upgrade a requirement without any repercussions, I do it, even though it's technically out of the scope of the pull request. Because this goes along with the Boy Scout rule. There's also a cost to creating a pull request. The easiest way, if you just have a culture of making it easy to keep everything up to date, you'll have a good time. You don't have to upgrade, especially if you're running your own private PyPI server. But you'll find that Googling documentation is painful when you're trying to find an obscure version. But the thing is, this approach only works when you have good test coverage. Something that I really want to try, but I haven't done yet, is I always pin the exact version in my requirements file. So I've often thought about, like, what if I had a special Jenkins job that just stripped versions and just tried newer versions, so it would just tell me once in a while if there's a newer version of a dependency that broke something. That's something I've always wanted to try. And now maybe one of you will do it and tell me how to do it. But minimizing technical debt may not be the, well, there's lots of ways to do it. One thing at the Texas Tribune that like the one thing that helped us with technical debt probably is something that I call the Taco Bell feature. And the idea is, if you have a Django site and you have a portion of the site that you know is never going to change, you can freeze it, spider it, store it as a static site, and just proxy out to it. It's no longer maintainable, but it also frees up the rest of your code. So a really good example for that is the Texas Tribune has a festival every year, and we were running 3 or 4 different versions of we're trying to run 4 different festival sites. It's like if you're trying to run every version of PyTexas from the same site. So when we froze that, we were able to delete like 70% of the code base. Whenever you're writing a new feature, you should decide up front, are we going to care about technical debt when we're doing this? Because sometimes you may want to, here's my crude hand-drawn thing. If you just need to get a proof of concept out there as a demo, and you decide up front as an organization, we're not going to care about technical debt, let's just get this out there, you should be cognizant of that's the decision that was made, so that when you do need to add something and do run into technical debt later, you know why it happened. Something I also like to do a lot when I'm doing something quick and dirty is I will write stuff sloppy on purpose. I'll have like really bad flake errors, and I won't do weird indentation. I can't bring myself to do that, but I'll do other weird non-PEP8 things, just so that when you're reading the code, you can tell it's crappy. Because I've definitely gone through a lot of like beautiful, well-tested written code, and then once I started to read it and understand it, I realized, oh wait, this is just like someone barfed this out, but was so obsessed with syntax that they spent all this work to make it pretty. Another thing that comes up, this comes up in pretty much everything, especially with, I learned about this from this old house, but when you have a contractor, they say pick 2 between good. You can have something good, fast, cheap, pick 2. And I just also wanted to note that you can also just pick one of these things, but then you are a bad developer. So like I write bad code once in a while, and I do it messy. I have like rules of thumb, because like we've got to be always thinking about delivering value to our companies. It's like my general rule is if I can fit everything in one screen of code, then I can kind of write it sloppy. And just make sure when you're writing disposable code, it can be that it's truly disposable. So it's really important to have a good API design, because if you have a really great API and you fulfill the design of the API, you can write something really quick just to satisfy that, just to get out the door, and then replace it wholesale later. So this is a subject that I've been really interested in for a while, and here's a lot of, it says reading, but these are all actually videos for talks. The first one says Docker and DevOps, but there's actually has nothing to do with Docker at all. It just happened to be given at DockerCon. That's was a really influential talk for me. And I even read real things to go along with this too. And I actually read an actual book about technical debt. It's called The Phoenix Project. There's no link to it. So if you happen to be in a bookstore, it either looks like that or like that. And there's like so many similar discussions going on out there. So like microservices versus monoliths, the single responsibility principle. Not invented here is something that I see all the time. Just feature creep and just general product development practices can influence how technical debt is made. So I guess my homework for you is, this was originally a much shorter list, but I kept adding things. That's like, get frustrated when something happens at the office and it's frustrating. You should get frustrated and you should think about how it can be fixed. I'm pretty lazy. I think you should be lazy too, because you should never have to worry about something being tedious. Like always work, and also work on getting faster feedback loops with every single process. Always make sure that you're touching, like visiting all your code base. As an organization, make treating technical debt as a feature. As you're coding, clean as your code. My slide for that was a kitchen, and if you want to learn more about that, I guess I would look at clean as you cook. Having just a generally good and healthy code culture atmosphere is really great. That's why I'm at tabbed out. It's also like look beyond the feature. Is your code repeatable, maintainable, documented? And it's also really important from the get-go to plan ahead for the whole life cycle. Is this something that you know you're going to throw away? Is this something that you're going to maintain? And thanks a lot. My slides are online. You can also run my slides as a Docker image too, if you want. If you look at the URL, that'll take you to the GitHub Pages link where you can view it. So I also gave this talk at DjangoCon, and I've updated it. So after this, I'll make a tag. So I don't know why, but if you wanted to see the DjangoCon version, you could versus this one.
It seems to me that one of the major things that would be involved in making this happen in an institution would be selling it to management.
Yeah, that's
management generally receptive to the message.
That's something that I haven't had a lot of experience with. The way we solved it at Tabbed Out is by hiring good product managers who are good at talking to management, who have that experience. And a lot of times, so management understands that engineering is not able to build things, and so somehow that gap just needs to be communicated, that the reason why things aren't getting built is because of technical debt.
One thing I'd throw out there too from a management standpoint is the Phoenix project, at least in Fidelity, is really popular among managers, partly because of how it is as a read. I mean, it's something that, you know, it's a very straightforward read. You don't have to be technical to
Yeah.
read it. In fact, it's actually really compelling to read, and to your point about how it helps fill in managers about the real kind of challenges that happen with software in a relatable kind of way. So I think at Fidelity, the Phoenix project kind of took off, and managers understand that that's helped change the culture, bring about DevOps, and bring about, you know, a lot of these things.
Yeah, Gene Kim was one of the authors of that, and I threw in a lot of quotes in there, and a lot of my reading is from him. And one illustration he had that I really like is, if you think of technical debt as data center wiring, I mean, just it was a great illustration. It's like, how do you fix this problem, and how do you? We all know how this happens, but now what? Also want to show this corgi. Oh,
Really simple, but can you go to your GitHub page and show how to get to the top? Like, I'm confused as to what's going on there.
I don't know what this is. Is this going to be it? No, it's my pie crust. So I do have a pretty good pie crust recipe on my GitHub.
I put the link in the PyTexas chat room too, if you want to click on it there.
Oh wait, I think I click. So if you go to this link, it's a. Oh wait, what? Oh, I messed that up. I'll fix that later.
So that link.
Yeah, there'll be a link there that actually takes you to a clickable version. And there's also a. I can't see what I'm typing. I'm just going to hit enter. Oh yeah, yeah. Okay, I'm going to disappear now.